Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 10, Lesson 1 on basic geometric formulas. Unit 10 is all about geometric measurement. In other words, things like perimeter, area, volume, surface area, things like that, right? So today what we're going to do is we're just going to start to review some really basic formulas like the area formula of a rectangle, the area formula of a triangle, perimeters of both types of figures. That's it. And then in future lessons we'll get into more complicated stuff, including this year taking a look at how we find the circumference and the area of a circle. All right, but for now, let's jump right into our work with basic geometric formulas. Now, one thing I would say is that today we're going to be doing a fair amount of work using our calculators, so make sure to have those handy for yourself and ready to go. We make measurements of physical space in many ways, including measuring angles from the last unit, but we can also measure perimeters and areas of closed figures. So let's jump in number 1 to do one of the most basic types of figures, a rectangle. A garden in the shape of a rectangle has a width of 18 feet and a length of 35 feet. The garden requires fencing to be placed all around it at a cost of $5.75 per foot. Notice that rate. It also requires soil to be placed over its entire surface area at a cost of $3.50 per square foot. Letter A, to calculate the cost of the fencing that surrounds the garden, will we need the perimeter or the area of the garden? Explain. Fantastic. So it's really important when you're working with geometric measurements like perimeter and area to know which one you need for a particular application. Now we're told, right, that we're going to put fencing around this garden that's going to cost $5.75 per foot. Okay, so which one of the two measurements, the perimeter of the rectangle or the area of the rectangle, do we need to calculate the cost of the fencing? Pause the video now and just write down which one and why. Well, we're going to need the perimeter, right? The perimeter is literally the distance that surrounds an object, okay? And that's where we're putting the fencing. In fact, you can kind of tell that it's the perimeter because it's $5.75 per foot. Not per square foot, but per foot. So we're going to need the perimeter because the fencing goes around the garden. All right. Now, letter B asks us to calculate the cost of the fencing. All right, great. So we want to calculate the cost of the fencing. Pause the video now and see if you can figure out the cost of the fencing. Well, we know that the price of the fencing is $5.75 per foot, right? That nice unit cost, $5.75 per foot. So the first thing I need to know is simply how many feet surround this object. I need to know the perimeter, right? Now, one way to do the perimeter of a rectangle is to literally add up all the sides. So I could be like 18 plus 18 plus 35 plus 35, all right? Or I could do 2 times 18 plus 2 times 35. Now, you could surely do this without a calculator, but there's also no reason why you can't just type it in, right? 2 times 18, I don't even need to use the times button, plus 2 times 35. And my perimeter, right, is 106 feet. Now, that's not exactly what I'm looking for, right? What I'm looking for is the cost of the fencing, and yet I know that the fencing is going to cost $5.75 per foot, right? So I can take my $5.75 per foot, I can multiply it by 106 feet, I can move my calculator to give myself a little bit of room, and I can now say that my fencing must cost $5.75 times 106 gives me 609.5, but keep in mind, right, we're talking about money, So it makes more sense to write it as $609.50, right? $609.50. Great. Let's keep going. Let me move this out of the way. Bring the problem up a little bit. Letter C. To calculate the cost of the soil to go inside the garden, will we need the perimeter or the area of the garden? Explain. All right, well, why don't you figure that one out? I just want perimeter or area and why. Not surprisingly, right, we're going to need the area. All right. And again, let's take a look at the rate that they gave us for covering the garden. Right, $3.50 per square foot, right? The square foot is one of the many ways or one of the many units that we use to measure area, right? So since we're putting this, this soil on a square foot, a square that's a foot by a foot by a foot by a foot, right? We need the area. Right? So the area, because we are covering area with soil, as opposed to like surrounding length, right, with a fence, we're covering area with soil. Now I'd like you in letter D to calculate the cost of the soil. All right, pause the video now and see if you can figure out how much the soil is going to cost. Well, the first thing we need is the area. All right, and hopefully you remember from many, many years, let me bring it up here, that the area of a rectangle is going to be its length times its width, so 18 feet times 35 feet. All right, let me just bring this up a bit and bring out my calculator again. Try to bring my calculator out again. It's only being somewhat helpful. 18 times 35. So my area is 630 square feet, right? So my cost is going to be 630 square feet times $3.50 per square foot. Right? And that I can just hit times 350. That gives me $2,205. All right. So simple enough, right? Perimeter measures the distance around an object. Any object that has straight sides, the perimeter simply is the sum of all of those sides. The area, specifically here, of a rectangle is how many square feet, square yards, square inches, square centimeters lie inside of an enclosed figure. Now, for a rectangle, right, we can summarize both the perimeter and the area formulas very simply, right? So for a rectangle with a length of L and a width of W, the perimeter and the area are calculated by perimeter equals twice W plus twice length, right? We take two widths, two lengths, and we add them together. And the area is simply the width times the length or the length times the width, right? Obviously, it doesn't make a difference in terms of that product because multiplication is commutative, right? 3 times 4, 4 times 3 is going to give me the same thing, okay? So easy formulas to use, but you have to also understand when you use them. Now, let's take a look at a slightly more challenging problem. Exercise number 2. Calculate the area of the figure shown below. Show the calculations you use. All right, well, obviously, this is not a rectangle, but area measures the space inside of a figure. So if I can carve this figure up into multiple rectangles and find the area of each, then when I add them together, it will give me the total amount of area that is within this figure. So see if you can carve this figure up in order to calculate its area. Pause the video now. Well, there's a lot of different ways that you can do it, all right? For me, the most obvious way is to sort of bring this line up like this, all right? So we have rectangle 1 and rectangle 2. Now, rectangle 1, I know everything I need to know about it, right? It's got a length of 31 centimeters, it's got a width of 22 centimeters. It's this one that's a little bit more challenging. But of course, I know that this entire length is 55 centimeters. I know this part of the length is 31 centimeters. So, if I just do a little 55 minus 31 and I get 24, that tells me that this is 24 centimeters. Since I know that this is 16 centimeters and this is 24 centimeters, I now have enough to calculate the area of rectangle 2. So here we go, right? The area of rectangle 1, and it's helpful to kind of have them labeled with those numbers, is going to be 22 times 31. Again, no need to slow ourselves down. We can just 22 times 31 gives me 682. Area 2 is going to be 24 times 16. Let's clear that out. 24 times 16 gives me an area of 384. And then obviously my total area is going to be just those summed. And that should be easy enough. I love my visit from red there. I'm going to just do answer plus 682. And that's going to be 1,066. Now I should always include correct units when I can. That's going to be 1,066 square centimeters. All right, that's it, right? And that's an important thing, right, that we can do with area, but you can't really do with perimeter, right? If I had to figure out the perimeter of this, I would never want to draw this line in, figure out the perimeter of this rectangle, figure out the perimeter of this rectangle, because quite frankly, that would then include this little line segment that I drew in, twice in fact, where it doesn't surround the overall figure, right? And it's a big difference, right? Perimeter is simply, if I just walked along here, walked here, walked here, walked here, etc., right, how many centimeters would I have walked? But area is literally how many little square centimeters fill up this space, right? That's what I'm counting with this 1,066. So if I figure out how many sit inside of here and how many sit inside of here, I can add them together to get the total two-dimensional space that lies within this object. All right, let's keep working. So rectangles, you gotta love a rectangle, right? Rectangles are fantastic because their area is so easy to find, their perimeter is pretty easy to find. So let's take a look at triangles now. Exercise number 3. Right triangle ABC is shown below, or show below. Let's put a little shown in there, yeah. Right triangle ABC is shown below, fantastic. Letter A, find its perimeter, use appropriate units in your answer. All right, well this hasn't changed from the last problem, so why don't you pause the video now and figure out the perimeter of this right triangle. All right, simple enough, right? Because we just need to add up the distances of all 3 sides, or the lengths of all 3 sides, right? So I'm going to simply have 6 feet plus 8 feet plus 10 feet, and that's going to be 24 feet. All right, easy enough. Now, right, perimeter's perimeter. You add up all 3 sides, 4 sides, 5 sides, I don't care how many sides. You add up the lengths of all the sides, you've got the perimeter. Area is trickier, right? So letter B asks us, how can you use a rectangle to help calculate the triangle's area? All right, so think about this a little bit. How can we use a rectangle, whose area is length times width, to calculate this triangle's area? Well, that's kind of cool, right? So this triangle is just half of a rectangle, right? So I can find the area. I can find the area of a rectangle with the same base and height well, actually maybe I should say width and length, but whatever, base and height, and then take half of it. Right? Because that's what a right triangle is. A right triangle is simply half of a rectangle, right? And you can see that as soon as we draw that rectangle in. So if I wanted to find the area, right, I would look at this rectangle. That 10 is totally irrelevant at this point. I would say, well, this rectangle, right, this rectangle has an area of 6 times 8, or 48 square feet. Whoops, 48 square feet. But the triangle is only going to have half that area. So it's got an area of 24 square feet. Now, by the way, I would be a little bit remiss as a math teacher if I didn't point out something about this particular right triangle. All right? This particular right triangle is one of those rare figures where its perimeter and its area are numerically the same thing, right? So they're both 24. The perimeter is 24 and the area is 24. But keep in mind that even though those numbers are the same thing, you couldn't get two answers that are more different. What I mean by that is that literally that 24 feet, right, if I kind of marked this off, is just this distance. If I took out a tape measure, 6 plus 8 plus 10, 24 feet long, right, if I unwrapped the perimeter. On the other hand, this 24 square feet literally is referring to the fact that if I started to draw square feet in here, right, and I calculated how many were going to be sitting inside of this figure, there'd be 24 of them. So yeah, you know, both the perimeter and the area are equal to 24, but 24 very different things. 24 feet in this case, 24 squares in this case, specifically squares that are a foot by a foot by a foot by a foot. All right, had to point that out. It was too golden of an opportunity. Now, the amazing thing about triangles is that the area formula for a triangle, right, which is base times height divided by 2, or 1/2 times base times height, right, which comes directly from a right triangle being half of a rectangle, okay, it works for all triangles, all of them. Okay, and we want to take a look at that yet again in exercise number 4. Let's take a look. For triangle MNP, a line segment has been drawn from P perpendicular to side MN. This type of segment is called an altitude of the triangle. You might just call it a height. Letter A, find the area of triangle MNP by finding the areas of triangle MQP and triangle NQP and then summing them. In other words, right, we've really got two right triangles in this picture. Let me label them triangle 1 and triangle 2, right? Two right triangles. And we know for certain that each one of these right triangles is simply half of a rectangle, right? So what I'd like you to do is find the area of triangle 1 using 1/2 base times height. Then find the area of triangle 2 by doing 1/2 base times height. Then add them together to find the total area of the triangle that I care about. Pause the video now and go ahead and work through that. All right, simple enough. So the area of triangle 1 will be 1/2 times its base times its height. By the way, keep in mind, right, that multiplication is commutative and associative. So I can find 1/2 of either one of those two numbers and then do the product after that. That's my technique at least. So in the other triangle, we have 1/2 of 6 times 5. And what I mean by that is I'm going to take 1/2 of 6 and I'm going to get 3. Then I'm going to do 3 times 5 and get 15. Right? So my actual area is going to be 25 square inches. Okay, simple. Now let's take a look at letter B though. All right. Now find the area by multiplying the base times the height and dividing by 2. In other words, this technique is great, it's wonderful, but oftentimes all you'll know about a triangle will be its height, 5 inches, and its base, 10 inches. Okay? But the great thing is that this technique works, i.e. area equals 1/2 base times height regardless. So let's actually take a look at that, right? You know, without actually breaking this thing up, I can just say, hey, the area is 1/2 of my base times my height. And again, I can do 1/2 times 10 and get 5. And then I can do 5 times 5 and get 25. And again, all I wanted to do here was verify that both techniques work. Now, in all likelihood, you're going to want to do this. And the reason you're going to want to do this technique is, one, it's faster. There's only one calculation. And two, oftentimes, when we're given a diagram like this, all will be shown is something like this: 10 inches, 5 inches, and we won't know how that base breaks down. We won't know if it's 7 and 3 or 5 and 5. Honestly, it wouldn't matter, but since we wouldn't know how it's broken down, it would be harder to do this kind of manipulation. All right, let's take a look at one last triangle. Simple enough, exercise number 5. Find the area of the following triangle to the nearest square foot. All right, so far we've been dealing with measurements that are really nice. You know, everything's been a whole number so far. But of course, in the real world, rarely anything in terms of measurement is a whole number. So now let's say we had this triangle whose base was 26.1 feet and whose height was 12.7 feet. I'd like you to figure out what the area is, and then I'd like you to round your answer to the nearest square foot. Pause the video now and see what you get. All right, well, here we go. Let's first just write down our formula. Right? Our formula is going to be 1/2 times 26.1 times 12.7. Now, if you like this formula better, 26.1 times 12.7 divided by 2, they both work great. Whether you're multiplying by 1/2 or dividing by 2 is completely irrelevant, okay? Order of operations doesn't care. Multiplying by 1/2 and dividing by 2 are the same thing, whichever one works better for you. Now, you might actually find this one to work better because you could do this product, get an answer, then hit divided by 2, get another answer, and boom, there's your area. This one's a little bit harder, but you could still do it that way. In fact, I would just type the following in. I'd do 1 divided by 2, that's 1/2, times 26.1 times 12.7. All right, and that area would be 165.735. We'll round that in a moment. Let me just show you the other approach because it works well as well. You could do 26.1 times 12.7, get an answer, then divide that answer by 2, and it also gives us 165.735. So whichever one that you're more comfortable with, and it may depend on what the context is. Maybe you like this one more when the measurements are messy, and this one more when the measurements are nice. Doesn't really matter. Now it asks us to round to the nearest square foot, all right? So I want to round to this nearest whole number. Because that's a 7, I'm going to bump that 5 up to a 6, and my area is going to be 166 square feet. All right. And oftentimes we do rounding like this, and we do it because, quite frankly, that might be close enough, right? It depends. It depends on what exactly I'm doing. If I'm looking at a garden or something like that, maybe I just need the square footage to the nearest square foot. Maybe I don't need it to the nearest 1,000th as it is here. Okay? Let's wrap this up. Let me move this out of the way. So today, what we saw were just some review of basic geometry formulas, right? We looked at the area and the perimeter formula for a rectangle. We also looked at the area formula for a triangle, and I guess the perimeter formula for a triangle. Perimeter formula is pretty much the same for every figure. Add up all the side lengths, right? That's pretty simple. Area can be a little bit more dicey, and oftentimes area formulas depend on the exact figure. For a rectangle, the area is simply width times length, length times width, base times height, whatever you want to call the two dimensions. On the other hand, for a triangle, right, the area formula is always base times height divided by 2, or 1/2 base times height. And that's because right triangles, right, are simply half of rectangles, and therefore we would expect their area to be 1/2 the formula for a rectangle. All right, well, we're going to use the rectangle and area formula and triangle area formulas way more in the next lesson when we start to look at trapezoids. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.